Okay, we want to look at how we can use our calculator to calculate binomial probabilities. Let's use these problems to look at the examples. It says 45% of blood donors have blood that is group O. Find the following probabilities regarding 5 donors. Okay, so the first thing you need to do is verify for yourself that this is a binomial distribution. Okay, so once you've done that, in this first problem, we want to find the probability that exactly 3 of the 5 donors have group O blood. Okay, so on the calculator, we're going to use the binompdf function. And to get there, we'll hit the second key and then vars. And then you can arrow down until you get to option A, or binompdf. And the syntax for this function is npx, where n is the number of trials, p is the probability of success, and x is the exact number of successes. So in our problem, n was 5, p is 0.45, and x is 3. Okay. Some of the calculators, instead of giving you the function like this, will show you trials, P, and X. And if it does, you need to put in 5 for your trials, 0.45 for P, which is the probability of success, and then 3 for X. And then arrow down to paste, hit enter, and then it'll paste the function on the screen the way that you see it here. And we'll hit enter to get our answer. Okay, so we used binompdf to get the probability of exactly one x value. Okay, so the probability of exactly 5 or exactly 3 successes would be 0.2757 approximately. Okay, now in the same problem, we want to find the probability that at most 2 of the donors have group O blood. So when we talk about at most, we're looking at 0, 1, and 2. Okay, so 2 ways we could do this. We could use binompdf and calculate the probabilities for 0, 1, and 2, and then add them manually. Or we can use the binomcdf function. Okay, this function is a binomial function that adds probabilities from 0 to the x value that we specify. So this is how it would work. We're going to go to second, distribution. Okay, this one is choice B. So I'll say alpha B, or you can arrow down if you haven't remembered which one it is. Okay, the syntax is still npx. So we're going to do 5, comma, 0.45. And I'm going to put in 2 because I only want it to add probabilities from 0 to 2. And hit enter. Okay, and so we get 0.5931 is the probability of having at most 2 have group O blood. Okay, and then the last example, it says find the probability that at least 3 of the 5 donors have group O blood. Okay, and so to do that on the calculator, we can still use binomcdf. If we're talking about at least 3, that would be 3, 4, or 5. And so that means we don't want included in that 0, 1, and 2. So what I would do is say 1 minus, and I would use my binomcdf just like we did in the previous part. So that was alpha B. Okay, n is 5, p is 0.45, and x is 2. Okay, in this case, I'm putting in 2 so that it will add up values up to 2 and subtract that off because that's not a part of what I want. I want at least 3. So I'm going to throw away 0, 1, and 2 by subtracting that total from 1. And so when we hit enter, we get 0.4069.